Good day, everybody. This is Chris with the Ancient Scholar. I hope this video finds you all doing well. So I just got back from the Venom Symposium in Rodeo, New Mexico, where the focus was primarily on viper envenomation and how to address it in the context of rural healthcare in the rural southwestern United States. So thinking about parts of California, Arizona, New Mexico, and even parts of Texas. And the primary focus of this particular conference was around so-called pit viper envenomation. And pit vipers belong to a larger category of snakes known as crotalids, and these include the rattlesnakes, the water moccasins, sidewinders, etc. These are the so-called pit vipers. And then the other major category of venomous snakes, at least here in the United States, include the elapids, which around the world include things like cobras and fertilances and snakes like that. Here in the United States, it really only pertains to one major type of snake, and that is a type of coral snake, although that's not what we'll be talking about today. So what I want to talk about in this first little high-yield discussion regarding some of the information that I found really interesting in this conference was a general way of conceptualizing different types of snake venom. And the general way that we can conceptualize the venom is according to some of the major substances, toxins, and or enzymes contained within the venom. Now, snake venom is actually incredibly complex, and it contains a multitude of small and large molecules that have a variety of effects. But this is just a way of conceptualizing it, just to kind of make it a little easier to understand. And so a way of thinking about crotalid venom is it belonging to a couple of different categories and what we call types. You have what are known as type A venoms, and type A venoms seem to be dominated by a neurotoxic molecule, an enzyme known as phospholipase A2 or PLA2. This is also referred to as the Mojave toxin, or MTX. This is a heterodimeric molecule, so you have these two dimers that come together to form the larger molecule. All right, phospholipase, so you know it's involved in breaking down interacting with the phospholipids in cell membranes, specifically the cell membrane of neurons, and it acts essentially to prevent the presynaptic neuron from releasing acetylcholine into the neuromuscular junction that then activates nicotinic acetylcholine receptors, and that's one of the primary mechanisms by which muscles are depolarized, and then they can contract as a result of that depolarization. And so the Mojave toxin, or the phospholipase A2, that is found in type A venoms, that would be its primary mechanism of action as a neurotoxin. And then you have what are known as type B venoms. And type B venoms are venoms that don't have the phospholipase A activity, or not as pronounced, but rather these are venoms that tend to have more metalloproteinases, or something referred to as snake venom metalloproteinase, or SVMPs. And the SVMPs are really important because the metalloproteinases and some other molecules like them tend to have more cytotoxic effects. So they cause swelling, inflammation, pain, tissue breakdown, etc. And this is the more quintessential findings that you would associate with a snake bite, a crotalid snake bite, tend to be more the result of these snake venom metalloproteinase or SVMP molecules. And so that's a type B venom. So type A, neurotoxic, type B, cytotoxic. And then there are some people that even say there are other types that are high in what are known as myotoxins, and these are toxins that cause destruction of muscle in addition to some of the other tissues. So there are some people that kind of think there may be a third type. And then what happens is you can have crossover or hybridization. You could have venoms that are have both type A and type B features, so they contain both phospholipase A2 and snake venom metalloproteinases. And then you can also have venoms that are high, that have high expressions or low expressions of these myotoxins. And so essentially it gives you can think of 6 major categories of venom. The first major category is the type A. The second major category is the type B. The third major category would be a hybrid, a mixture of type A and type B venom. The fourth major category would be a type A venom with high concentrations of myotoxins. The fifth major category would be type B venoms with these higher concentrations of myotoxins. And then the sixth major category would be a hybrid of type A and type B venom that are also have high expressions of these myotoxins. So the traditional way in which we think about venoms has been challenged a bit with this conference, and I have to admit that I kind of thought this way. A lot of people still think that the Mojave rattlesnake, which is a much more common in areas of California and a few areas in Arizona, the Mojave rattlesnake, a lot of people associate that with being the most quote-unquote deadly rattlesnake that creates the most deadly venom because this is super neurotoxic type A venom, and this causes the neurotoxicities that kill people, respiratory depression, and so on and so forth. When we actually look at the literature, we don't see a whole lot of this. Just just a small handful of human beings that have actually died or become seriously ill as a result of envenomation with Mojave rattlesnakes. In fact, I believe the biggest share of morbidity and mortality from snake bites, from crotolid snake bites in the United States, comes from the timber rattlesnake, which may or may not have the type A venom, and some of the more severe kinds of envenomations that we see tend to be more of the cytotoxic and myotoxic effects, where you get the swelling, sometimes you can get tissue necrosis, muscle breakdown, you can get liberation of bradykinins and other cytokines that can cause a reduction in blood pressure, and this can also cause acute kidney injuries, and so on and so forth. And that seems to be the lion's share of the morbidity and mortality, not necessarily all these neurotoxic effects. And so this sort of challenges the traditional thinking of the Mojave rattlesnake and these venoms that are high in these so-called Mojave toxins as being a major contributor to morbidity and mortality. They really don't seem to be. Even though when we test these different types of venoms on small animals, rats and so on, this does seem to be consistent with what we think, right? The type A venoms are pretty nasty to the rats with their neurotoxic effects. Why aren't we seeing this in human beings? We don't really know. We need to do more research. We need more data. There may be several reasons. There may be some odd biological differences in human physiology that could account for some of this. It may be the snake behavior that could account for some of this, and there is good evidence to suggest that snakes act differently when they are acting as predators. So when they're actively hunting something, and the kind of bite that they do and how much venom they deliver and so on and so forth, versus what a snake may do in the defensive context, because snakes don't want to eat human beings. We're too big, and so when a snake bites a human being, it's not out of a sense of hunting. It's more that snake feels that it's in danger and that there are no better options at that point in time, and so it bites. And the biting behavior and the type of envenomation that could result from a predatory versus a defensive bite may actually explain this, or it may be something completely different. Either way, I thought this was a really interesting and really compelling bit of information that I was able to glean from this conference, and there will be additional discussions forthcoming, but I just wanted to get something out real quickly. So now I got to get unpacked. I need to do some laundry. I want to take a shower, go to the gym, and so on and so forth. But I'll try to get this video out and uploaded to give you a taste of some of the clinical vignettes that are yet to come. All right. Thank you all so much, and take care.